Yo everyone, welcome to Grasp Mathematics, where I teach you how to understand mathematics and not memorize anything. Please, if someone's telling you to memorize something, don't listen to them. Mathematics is all about understanding. I don't memorize anything. I understand concepts, and in that way, you understand mathematics, and it will make a huge difference in your life. So, today we are going to be talking about solving and manipulating equations. One of the most important things you can do in mathematics, and one of the most important things to understand, both in math, in physics, and in any sort of problem solving. So there is one rule, not to memorize, but it's logical, is what I do to the left, I do to the right. That's what your teachers always tell you to do. What you do to the left, you do to the right. What you do to the left, you do to the right. But here I'm going to teach you how to understand that concept. My way of thinking about it is that I want to keep the equal sign true. Keep the equal sign true. That is the most important thing. A lot of students just put equal signs everywhere they want, and it doesn't make sense. If you want to start understanding mathematics, you have to understand what an equal sign does. It is telling me that what is on the left of the equal sign is equal to what is on the right of the equal sign. Therefore, if I change the left-hand side of an equation, I'll have to change the right-hand side also to keep the equal sign true. Okay, well, let's start with some easy examples, and then we'll get on to some more difficult ones. So, what we have here is I'm going to solve for the unknown. I'm going to solve for x. So therefore, if I'm solving for x, I need to get x by itself. X is equal to something. That is my aim. Get x by itself. So remember, logic tells me if I do something on the left and the left is equal to the right hand side, therefore I have to do it on the right hand side for this thing to be true. Otherwise it's not. So if I'm trying to get x by itself, in this case, I want to divide by 2, because 2 divided by 2 is 1. Then I'll just have 1x, which is just x. So if I divide by 2, right now the left hand side is not equal to the right hand side. This is not equal. In order to make it equal, I'll have to divide the side by 2 also. And that is the most basic concept of equations. Now, 2 divided by 2 is 1, so 1x, which is just x, is equal to 4 divided by 2 is 2. Okay, so we stick to that concept all the time. And you can manipulate equations any way you want if you just stick to that concept. But remember, when you are affecting the left-hand side and affecting the right-hand side, you have to do it to the whole side. If you are dividing here, you have to divide the whole side. And dividing here, you'll have to divide the whole side. So you have to be good or understand you have to have an understanding of dividing fractions and how those work also. So over here, we want to get x by itself. Now I've got x minus 2. In order to remove a negative 2, I need to add 2. Some people think, but you divided here. Well, I divided here to make 1. If I divided here by 2, I have to do it to the whole side, divide by 2. That does not remove the 2, because x is being divided by 2 and negative 2 is being divided by 2. So in this case, I add 2. And if I do it to the left, I have to do it to the right to keep the left and the right equal. Okay, so in this case, I'll have x minus 2 plus 2. This becomes 0. And I have x is equal to 4 plus 2 is 6. Now let's incorporate both of these two things together. Okay, so now you might ask yourselves, do I add, do I subtract, do I divide, do I multiply? Over here I see a 2, so should I divide it by 2? Well, you can do that, because if I divide this by 2, it's the same as saying this. Divide this by 2, divide this by 2. I have to divide the whole side by 2. And therefore divide this side by 2. That's fine also. But the more common way to approach it is get all the terms that are not associated with x away. Remove all the terms. So here I've got a 2x. Let's leave that here, and let's remove the negative 2 here. So I'm going to add 2 over here, and therefore add 2 on this side also. So right now I'll be left with 2x minus 2 plus 2 is 0, so just 2x, and equals 4 plus 2 is 6. So in this case now I've got 2 by itself. I can divide the whole side by 2. I've got 2x by itself. I can divide the whole side by 2 and divide the whole side here by 2. And in that case I'll have x is equal to 3. And there's your answer. Okay, these are quite straightforward, and we're going to get on to more complicated examples as this video continues. So let's move on. So here I've got x's both on the left and on the right hand side. So what I need to do is, remember my aim is to get x by itself. So that's my aim over there. Okay, well, if I want to get x by itself, I need to remove it from one of these sides. So that's what we need to do. So if I want to remove the negative 4 on this side, you could do it on the 5 also if you wanted to. I'm just going to stick to doing it on the right hand side. If I want to remove the negative 4, I need to add 4x. Okay, here I've got negative 4x. I have now removed the negative 4x because this becomes 0, but I also need to do it on the left hand side. So over here, 5x minus 3 plus 4x, the x's will add together and become 9x. And I've got negative 3 here. And here 6 minus 4x plus 4x, this becomes 0, so I've just got 6 here. And now we should be able to solve it from here. You can pause this video and try and solve it yourself. Before I continue, please, you need to try and do these things yourself. Students are really scared to make mistakes, where that is the only way we learn. So pause the video, try and solve it, and see what you get. So what we're going to do now, we want the x's by itself, so we want to remove the negative 3, so we need to add 3 here, and we need to add 3 here. So what I'll be left with is 9x. Minus 3 plus 3 is 0, and then I have 6 plus 3 is 9. Cool. In order to get the x by itself, I need to divide by 9, because 9 divided by 9 is 1, and 9 divided by 9 is 1, and therefore x is equal to 1. Don't be scared to make mistakes. You need to be trying to do the stuff yourself. I always make so many mistakes. Don't worry, everyone makes mistakes. Just try and do it yourself. So in this question, we don't like that there are brackets. The 3 is multiplying a bracket here, and the 2 is multiplying a bracket here. So we are going to expand. In order to expand, we need to take the 3 and multiply it to each term. So I'm going to multiply it, the 3 to the x, and the 3 to the negative 4. That would give me 3 times x is 3x, and 3 times negative 4 is negative 12. And on this side, the 2 does the same thing. The 2 multiplies to the first term, and the 2 multiplies to the second term. So what I have here is 2 multiplied by negative 2x is negative 4x, and 2 multiplied by 1 is 2. Now I'm in the same position. Pause the video and try and solve it yourself. Okay, so I want 3x minus 12. I want the 3x to stay by itself. I've got a negative 4x here. I want the x's to be on one side, or I want to remove the x's from this side. Please do not ever speak about taking things over to the other side. That is not a mathematical principle. I know your teachers might tell you that all the time, but they're wrong. It is not a mathematical principle to have a negative 4x here, take it to the other side, it becomes positive 4x. Yes, it does work out to be the same thing, but that's where you make mistakes, and that's where you don't have the understanding. You need to balance each side. On the right hand side, I want to add 4x to remove this negative 4x, and on this side I need to add 4x to balance out my operations. What I did on the right, I must do on the left to keep the equal sign true. So here I have 3x plus 4x gives me 7x, and I've got negative 12 here also. And on this side, my negative 4x plus 4x becomes 0, and I just have 2. Okay, so now I want the negative 12 to go away, because I want the x's by itself. So I add 12 here, and I add 12 here. So I get 7x equals, because the negative 12 and the positive 12 becomes 0, and here I've got 2 plus 12 is 14. I want the x by itself, so I need to divide by 7 in order for 7 to divide by 7 to make 1, and I need to divide by 7 here also. So in this case, therefore, that's what the 3 dots mean, therefore x is equal to 14 divided by 7 is 2. Okay, very good. So let's move on to a more difficult question. So here I'm looking to solve for z. Okay, so my aim is to have z by itself. Z is equal to something. And I can do any operation I want. I can add, I can subtract, I can divide, I can multiply, but I must do it to the whole side. Okay, so if you're looking at this, remember we want to get the z by itself. I've got z's on the right, I've got z's on the left. So what I want to try and do is remove the 6. This you can do it any way you like, as long as you stick to the logic. What you do to the left, you do to the right, and you have to do it to the whole side on the left. Therefore, I have to do it to the whole side here and the whole side here. Right now, this is a fraction, so we can pretend that it's in brackets. Okay, and this 6 is probably the most logical approach would be to remove the 6. Okay, so in order to remove the 6, we need to subtract 6 from the left, and we need to subtract 6 from the right. So in this case, 6 minus 6 is 0, plus this fraction. So I'm only left with the fraction, which is 3z plus 1 divided by 8. And on the right hand side, I've got 2z plus 11 minus 6 is 5 plus 5. Okay, very nice. So now we are in the situation where we have a fraction. We would like this 8 to not be there. We would prefer the 8 to be a 1, because anything divided by 1 is just itself. So if I have a fraction, and if you understand how to multiply fractions, I want to multiply this whole fraction by 8, or if you would like to say 8 over 1. Same thing. Remember, when we multiply fractions, the bottom multiplies and the top multiplies. But in this case, when I've got a fraction multiplying a fraction, I have 8 divided by 8, which is 1. So I multiply this side by 8 to remove the 8 on the denominator, and therefore I need to multiply this side by 8 also. 8 over 1 is the same as just 8. I'm just putting the 1 there so you understand the concept of fractions. Okay, so if we're going to multiply the 8 into this, the 8 would multiply here, and all I'd be left with is the 3z plus 1, because the 8 divided by 8 becomes 1. Okay, and on the right hand side, this 8 over here would have to multiply into both terms. Not only one term, into both terms, because I'm multiplying the whole side, not only part of the right hand side. Okay, so the 8 times 2 is 16z. 8 times 2z is 16z, and 8 times 5 is 40. Okay, now we are in the situation where we were in the previous examples. What we need to do is get the 16z to go away. We don't want that there. So what we need to do is subtract it from the side, 16z. Let's subtract 16z there and subtract 16z there. Okay, so what will happen now is we have 3z, subtract 16z, which is negative 13z. I still have a 1, so I add 1. And 16z minus 16z is 0, and I'm left with 40. Okay. So on this side, I want the z to be by itself, so I want this 1 to go away. So I'm going to subtract 1 here, and I'm going to subtract 1 here. So what will happen is I'll have negative 13z equals 40 minus 1 is 39. Okay, I still want z by itself. Right now the coefficient, which means the number next to z, is negative 13. Well, let's divide that by negative 13, so that negative 13 divided by negative 13 is 1, and divide this side also by negative 13. Can you see there is no memorization here, purely understanding. So negative 13 divided by negative 13 is 1z equals 39 divided by negative 13 is negative 3. If you ever want to test your result, just take the negative 3, put it into brackets here, and see if they work out. We can do that on the side. So if I ever want to test equations, the best way is just to put the left-hand side, put the answer into the equation and see if the left-hand side equals the right-hand side. So in this case, z is negative 3. So we'll say 6 plus 3 in brackets. You always substitute in brackets. Minus 3 plus 1 over 8. And on the right-hand side, 2 negative 3 in brackets plus 11. You could put this straight into your calculator if you wanted to, exactly like this on the left hand side, and see does it equal the number on the right hand side. But I can just do it quickly. 6 plus this is negative 9 plus 1 is negative 8. Negative 8 over 8, that becomes negative 1. Okay. And this will be negative 6 plus 11. 6, this is negative 1 because 8 over 8 is 1. So 6 minus 1 is 5. And on this side, minus 6 plus 11 is also 5. So we know that this is the correct answer because the left-hand side is equal to the right-hand side. This is the answer to my equation. Okay, and the last question, slightly more complicated, but it just is testing whether you understand fractions. So what I have here is an equation where I don't like that I have the ends on the top and on the bottom. So what we're going to do is stick to our logical approach to this. Right now, our logical approach was whatever we did on the left, we do on the right. So this thing right now is in a bracket. I have a numerator, I have a denominator. Okay, in order to get rid of this denominator over here, I need to multiply it by the same thing. So what I'm going to do is multiply this by 12n plus 15. It doesn't matter if you take the whole denominator, no matter what it is, the whole thing on the bottom, if you multiply it by that fraction, the same thing, 12n plus 15 over 1, this will divide by this and make 1. Therefore, I divide that whole denominator will cancel with that whole thing, or it won't cancel. You might hear the word cancel very often. It just means that it divides by itself and makes 1, and anything times 1 or anything divided by 1 is just the same thing. But on the left hand side, I multiplied by the bracket 12n plus 15, so on the right hand side I also need to multiply by that bracket 12n plus 15. Okay, so what am I left with? Just the numerator, 7n plus 13. And on this side, this will have to multiply both terms. So that'll be 12 times 2 is 24n, and 2 times 15 is 30. But I will also have to multiply this 3 in there. I'm expanding these because I want the n's to be alone by themselves. So 3 times 7 is 21 n, and 3 times 13 is 39. 24 n plus 30 on the right. Okay. So now we are in the same situation as we were in the previous examples. So what we're going to do is remove the 24n. You could remove the 21n. It doesn't matter as long as you stick to your principles. So I'm going to subtract 24n, and on this side I'm also going to subtract 24n, and I would get minus 21n minus 24n is minus 3n plus 39, and on the right hand side I've got 30 because 24n minus 24n is 0. So what I'm going to do here is remove the 39 by subtracting 39, and subtracting 39 on the side also. So right now I've got negative 3n, this becomes 0, and this becomes negative 9. I want the n by itself. I'm solving for n, so I need to divide by negative 3, because negative 3 divided by negative 3 is 1. A lot of students will just divide by 3, and that's a massive mistake that they make. You need to divide by the negative 3, because negative 3 divided by negative 3 is 1. If you just divided by 3, you would get negative n. We're not solving for negative n, we're solving for n. So I would divide this side by 3, and that would be n over there, and minus 9 divided by minus 3 is positive 3. Okay, so that's it for this video. I hope you enjoyed it. Please, you got to focus on understanding equations. If you have any questions, please comment, like the video if you liked it, subscribe. I'm here to help. Please ask me as many questions as possible, and I'll do my best to answer them.